What is artificial intelligence? I was talking with my uncle a couple of months ago. I said it was not complicated to use a classifier neural network as a loss function in order to improve a generative model. It works for images, and thus it should work for text. You should easily get a poor man's ChatGPT. He said, well, of course it is obvious. Now I can't call myself an expert in interpersonal relations, but I think his tone and face expression were meant to convey that it was in fact not at all that obvious. So I thought if my uncle, who mind you never has developed any artificial intelligence in his life, thinks it is not at all that obvious, then maybe I should try to explain what it is in order to make it less mysterious. Which arguably is strange coming from me. But not knowing what I'm doing never has stopped me from talking about it as if I were an expert, or from doing it in the first place. So, what is artificial intelligence? Artificial intelligence is machine learning. There, done. Thanks everyone for coming. See you next time. Joke aside, the term machine is interesting. We had machines back then when I was in school. They were a training device for arithmetics. Presented as a table, there was an input column and an output column. My task was to perform the operation on the input and write the result in the output. So in this example, 2 times 7 is 14. 3 times 7 is 21. And so on. Machine could be complicated and have intermediate steps like this second one. In this case, the intermediate step is the result of the operation times 7. And the final step is +1. I'll decide this is trivial and leave you the arithmetic demonstration as an exercise in order to feel like an important university professor. Now imagine a situation where the operation is not known. We only have the input and output at our disposal. Even the intermediate step is unknown. Machine learning is the art form of finding this operation and doing that automatically. We wouldn't want to work if we can have the computer working for us, wouldn't we? So machine learning must learn that the operations times 7 or times 7 plus 1. An artificial intelligence is a computer program that takes the input and gives the correct output using this operation we just have found. Or at least something close enough. I suppose now is as good as any moment to introduce that in fact we do not care about the operation we search for, nor do we care about the intermediate step. We only want a machine that takes an input and gives an output. While we build the machine, we can check that the output is close enough to what we expected. Then when we have entirely new inputs, we assume the output will be close to the correct value. And there should be a lot of care going into this assumption because we have no idea of what the true value is. In my opinion, the next logical question is, how does the machine find this operation? You don't have to follow the same logical leaps as I do, but regardless, I will talk about how to find this operation next. The very bad way to do it is to try. For the times 7 machine, we can try to see if a number gives a good result. So anything times 0 is 0. Anything times 1 is itself. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. And if you're starting to think that this is going to be a lot of maths, then you're perfectly right. There are an infinite number of different ways to do the times operation. That will feel long even on a powerful computer. And if we add pluses in the available operations, then we have even more maths to do, times 0 plus 0, times 0 plus 1, times 0 plus 2, and so on. Now we have 2 infinites. That will feel even longer, especially near the end. And we have yet another problem. How in all those numbers do we find the ones given by the correct operation? In all those columns, how do we know that the times 7 is the correct one? For that, I picked just 2 of those operations, times 3 and times 7. I can write the output of the machine in green next to what I wanted to see in black. Two numbers. I can compare them by subtracting them. 0 minus 0 is 0. 7 minus 3 is 4. 14 minus 6 is 8. And then I can add all those numbers together. 0 plus 4 plus 8 plus 12 plus 16 plus 20 equals 60. I can do the same for times 7. In this case, I get only zeros. I call this total number the error. It measures how good the operation is. The closer to 0 the error is, the better the operation. Now that we can sort through a number of operations and decide which is the best one, we just have to do this infinity of calculations. There's an infinite number of different ways to do the times operation. We can draw this as a line. Imagine that this line extends to infinity, wherever this is, and certain location on this line correspond to numbers. This is a way of drawing a small part of infinity and saying we imagine the rest. By which I mean we accept it as it is, and try not to think too much about it. That's the problem with infinites. We need to give ourselves power to do arbitrary things in order to deal with it. It's some form of art. At that point I'm an artist. I can do whatever I please. It pleases me to draw happy little infinity lines, so that's what we'll draw. Thus I'll decide that a vertical line will represent all the possible values of the error. Remember, we just found out that the error needs to be close to 0. Thus the region close to the first line is a small error and the faraway region, even below, is a big error. I can put a marker for each operation at the height of the error it obtains. And draw a line between the crosses. The best operation is when this line is closest to 0. A computer and an inhebriated line-folded engineer have about the same intellectual capabilities. So now, imagine this very engineer appearing somewhere on this line. He takes a step. Then you ask, have you gone up or have you gone down? If he says up, you tell him to go back. If he says down, you tell him to continue. Sooner or later he will descend to 0. And if you see a problem coming when he crosses under the line, then you're ready for more maths than I feel like doing today. This procedure is actually quite nice because if you draw in 3D you can add the pluses. And if you want to have logarithms, square roots and more convoluted operations, you can add lines. Because each operation you want to add is just a line to draw and a dimension to add to the picture. I won't show it here because trying to draw in more than 3D hurts my brain. And this procedure is even nicer because we can put it into a computer. This is what machine learning is about, constructing a wavy surface and finding the point where it's closest to 0. After that, an artificial intelligence is a computer program that uses this operation we found through question of the means in order to transform numbers into other numbers. I wonder whether they like it. Now that is really the end. Thanks for watching. See you next time. Or stay for a message from the sponsor of this video. Me. I'm the sponsor of this video. Have you drunk water? I have read somewhere that we should drink 8 glasses of water each day. I know I should not trust everything I read on the internet, but drinking a glass of water is probably a good idea. Bye now.